utilize the share feature again today as we review. Basically, I'm going to ask you to review, right? So one of the reviews that was in MOM for this chapter is a optional paper review, all right? So let's see if I can make this happen. And so there, I think is what let me know if you're not seeing, you know, that document on my screen. Maybe I did something wrong, okay? But you should be looking at review worksheet for chapter 5. Gotta let somebody in, here we go. Yeah, review worksheet for the chapter. And so I'm gonna invite you right now to graph this system and find the solution, all right? I have 2 copies here, so after I let you spend a few minutes on it yourself, then I'll click over on the other one where I've got my, my solution already worked out. All right, and come on, Steve, there. So maybe, hey, could just somebody just speak up and say, yes, we can see it. Just let me know I'm doing the right thing.
We can see it.
Great, thank you, thank you. So I'll just tell you, you know, this handout, this worksheet here has 11 problems. Your chapter test has 10 problems. Going to be very similar to this, probably fewer, what do you call it, word problems than what I have on this worksheet. So, and I've set it up as 75 minutes, so hour and 15 minutes for you to get through them. You know, pace yourself. Make sure you've got time to enter your answers if you're doing, of course, you're doing everything on your scratch paper, but anyway, don't run out of time. Hope that isn't a problem. But look at this first problem here. You've got 2 different forms of equations, right? That first one in the mx plus b shape, I would hope that you would use the intercept and that slope of 3/1 to graph that line. That second equation is in a form that would work pretty well for the intercept method. Put in 0 for x and see what y is and vice versa. Although I admit when I was doing my own answer key, I quickly rearranged that second one. I subtracted the x's and put it in the mx plus b shape. So that's not too hard if you really like that other technique. So, and so I'm gonna kind of go along at this rate here and try to give you about 5 minutes on each problem. And then we'll look at, you know, my work and see what kind of questions you might have. I'm sort of being lazy, right? Make you do the work and tell me where you have difficulties. All right. All right. So we're 5 minutes in. I'm going to click over to my other page. And again, just let me know if you don't see the solutions. You should be looking at my desktop. So I'm just clicking back and forth between 2 documents here. So, so here I graphed the first one, y-intercept of -1 and a slope of over 1 up 3, and found that second point. As I mentioned here, for when I did it myself, you know, some time ago quickly to come up with the answer key, I subtracted the x's, and so it was in that mx plus b shape again. But so there's +4 would have been the y-intercept if you use the intercept method, and over 1 down 2, right? And happened to be that same point right there that I found for the first equation. But there's the other intercept if you were using that intercept method, 2, 0 for the x-intercept. So there are roughly my 2 lines, and so that solution, ordered pair, right? X first, you know, I got 1, 2, right? 1, 2 for that ordered pair solution, all right? And so I'm just going to keep going like this, and you guys Please speak up if something's not clear. And, you know, I can even go back to the whiteboard at some point if I need to like explain things even more so, all right? So I'm gonna scroll up here to number 2 on that worksheet. These next 3 problems I've indicated you should solve using the substitution method. And if that happens on the test, if there's specific instructions for that technique, you're not gonna get credit if you don't use that technique, all right? Maybe you can do it the other way to confirm your answer or something, but you gotta show me this technique. So substitution method, here's that situation. Well, I've gotta choose one of those 4 variables to solve for. And I think there's one kind of easier choice than the other 4, than the other 3, all right? So I'll stop and give you time to try to work that out. Solve for one of the variables, substitute it in the other equation. Go from there. I'll just say I would have solved for y in the first equation. And so I'd end up with one big equation with just x's. So I'd be finding the x first. Just double check and make sure there's not somebody waiting. No, looks okay. I know you're, oh, well, anyway, I know I haven't graded your hand in homework number 9 yet. Probably be sitting around this afternoon and do it. I'll get it done. Sorry to keep you in suspense. Okay, I'm going to click over to my solutions and show you what I did. So again, I apologize if it's not totally clear. I was doing this for myself to come up with the answers some time ago. But here I solved that first equation for y, subtracted the x's, and so here's my expression for y that I plugged into the other equation instead of the y. Notice I needed those parentheses because I have to multiply it by that -2 basically, right? Distributed, minus minus got me plus 4x and plus 8. Combined the x's there. And I subtracted the 8. I didn't show you that, but subtracted the 8, got to -14. Divide by 7, x was a -2. Right, so big deal is coming up with a good substitution expression. Plug it in there and distribute carefully. Now I have to find the y value. I always say you could go back to either of those other beginning equations, but this one's already set up to tell me what the y value is if I put in that -2 for x. -2 times the -2 was a +4. Minus another 4, the y value just turned out to be 0, just by chance. Okay. So that's the way I went about that one, a substitute problem, where there was kind of an obvious choice for which one to use, right, for the y. That's was sort of the intent of that example. All right, on to the next then. Okay, here goes. And next one, same kind of problem, issue, right? This worksheet says 2, 3, and 4 should use the substitution method. So again, look at those two equations and decide which variable do you want to isolate. And I think there's a easier choice than others. You know, if we can keep up at this pace, like 5 minutes a problem, get through them all. I might jump in a little early for these first couple, make sure we have time for the word problems at the end. Very windy outside. Knocked over a pile of lumber I had leaning up in my carport. What was that? I'm going to jump in here, okay? And you let me know if there's a problem there. But here was what I did, right? Gee, is that, oh, wrong page. Wait, where'd it go? Oh, I copied them in the wrong order. My scan was in the wrong order. There we go. I solved that first equation for x, right? Subtracted the y's. So that was my expression, negative 2y minus 1, that I then put in instead of x, right? Again, parentheses, distributed the 2, negative 4y minus 2 plus 3 more y's equals 1. Combine the y's, negative y, and then added the 2 and got a 3. So y was a negative 3. I needed to find then the x value. Again, I went and chose to use this one that I solved for x. I did this work in my head, I'm sorry. Negative 2 times negative 3 got me positive 6, right? So 6 minus 1, I got an x value of 5. Draw your ordered pair in the right order. 5, negative 3. Oh, don't peek at that next one. Ha ha ha. Okay, 5, negative 3. Back to number 4, still substitution method. Here's one of those where they're both solved for y. And we have addressed that before. It's already ready for you to do substitution one direction or the other, it doesn't matter. Have a bunch of x's left. Here you have to move your x's around, get all the x's on one side, all the constants on the other, and go from there. What do you think? Good enough? Here goes. So I took that expression there and substituted into the other equation for y, and came up with this equation with just x's in it. Looks like I added the x to both sides to get 2x, and I subtracted the 7 from both sides and got -8. So 2x is -8, x is -4. Plug it into either one. Looks like I used the first one, right? Negative. Opposite of a negative. Negative of a negative was +4 minus the other one, and I get a 3. So -4, 3 for that ordered pair solution. And that was kind of a little of everything right there in terms of kind of substitution problems, right? Okay. On to some elimination problems. You know, if I want a specific technique, I'm being, real clear about that. All right. Number 5, solve using the elimination method. Take a look at those numbers. Here's the one that I say it's ready to go. Add the two equations together. Hopefully pretty quickly you kind of get 2x equals 10. So x is a 5. And then plug that back in to find the y. How's that, huh? Here's one where the y's were already same size, opposite signs. So adding the equations got me 2x equals 10. Divide by 2, x is 5. Plugging that 5 in. Looks like I used the first equation. 3 times the 5 got me the 15. Minus 2y equals 1. Subtracting the 15 left -14 over on the other side, right? Divide by -2 and got a 7 for my y value. Okay. All right, that's good. Here we go. And next one, you can just look at 6 and 7 and see what I'm doing. Now here, number 5 was like ready to go, add them together. Number 6, you're gonna have to multiply. I would choose one of the equations and have to multiply it to get the same size numbers. Looks like x or y would work pretty easily, not too huge in numbers. And number 7, you can see we're gonna end up multiplying both equations on number 7 to get to a common multiple. Try number 6. I forget what I did, but you can see I could multiply by -3 and get the x's to cancel out, or I could multiply by a -2 on the second equation and get the y's to cancel out. So probably a couple different versions out there amongst you folks. And well, as long as we come up with the same ordered pair point, it doesn't matter which route you chose. How about it? Here goes. Backing up, yeah, my pages are out of order. There. Oh, look at, I multiplied by a -3. I chose to get the x's to be the same. So that second equation became -3x plus 6y equals +15. Again, I was doing it for myself, so I didn't line everything up, but I added the first equation and now that third one, right? This is instead of the second. So I added the first one and the third one here. The x's cancel, the y's left 2y, and the constants 15, -11 left a 4. So I ended up with a y equals a 2. Now, if you got rid of the y's, then you found your x value first. But if y is equal to a 2, where did I put that in there? Right here, I guess. X minus 2 times 2 is 4. X minus 4 was the -5. Added the 4, got x was -1. Okay. Really, you know, 4s would have been smaller numbers, but they weren't that much different, you know, to get to be, you know, I didn't make huge numbers by going to 3s, right? All right, this next one. Looking at those numbers for 7, still trying to use the elimination method. And, you know, multiplying just one equation is not going to get you there. You're going to have to choose a common multiple for the x's or the y's, right? You could make the x's 15s without much difficulty, I hope, or the y's into 10s. Opposite signs already. So takes a little longer because you got to multiply them both, maybe an extra 30 seconds, huh? Is that okay? Here goes my number 7, huh? What did I do? I chose to get the y's to be the same. I got 10s, plus and minus 10. So the first equation times 2, right? 6x minus 10y equals -18. And that means the second equation times 5, 25x, 10y, and 80. The y's canceled out. 31x is 62. divides nicely to x equals 2. So if x equals 2, now I got to go back and plug that into one of them. It looks like I used the first one. 3 times the 2 was a 6. Minus 5y is negative 9. So subtracted the 6, negative 15. Divide by the negative 5. Y equals 3. So 2, 3. Nobody's slowing me down, so I'm going to assume that's all good, all right? And now back to number 8. Here we go. And still one more elimination method, I would think, here. That's probably what the instructions said, 5 through 8. Looks like you can multiply by just one of the equations again this time. Okay, if this is turning out weird, then you've done the right thing. See if you can remember how many solutions does it mean? And can you recall the classification term that describes this special case? You know, there was those independent or dependent, or consistent or inconsistent. You know, really one word kind of describes the special situation. You could remember that. Because it turns out to be kind of weird that there's fewer steps, you might say, right? If I took the first equation and multiplied by negative 2, negative 2x minus 6y equals negative 10, adding them together and the variables all canceled out. I got 0 equals negative 3, a false statement. There's that false negative connotation. So no solutions, right? No solutions. And we call that inconsistent. There's that, what I say, negative connotation to that term, an inconsistent equation. Remember the other unusual situation was where they might actually have been the same line, even though it was not obvious to begin with. And you would have ended up with something like 0 equals 0, which is always true, an infinite number of solutions for that situation if it happens. And we say those lines are dependent. They depend on each other, or they're tied to each other, something like that. Okay, hope that worked out well for you. And last page, I think, is my, here we go, my 3-word problems. All right. All right, here's one of our old favorites, haha. The perimeter of a rectangle, 100 feet. I even gave you the formula there, at least in this handout. And then there, so, you know, that formula basically is your first equation, right? The L's and W's are like X's and Y's, just turned around. And you get, that has to add up to 100 feet. And then you have to come up with that second equation based on the next sentence. And do your substitution. Well, yes, this is usually a substitution problem. As I mentioned, this review might have actually been one of my tests one term in the past, although I'm pretty sure I added an extra word problem for our review here. I've used this one for a couple terms. The instructions up there say answer with a complete sentence, and then what did I do? I just left you 2 blanks. So in the classroom, we usually ask you to write out a sentence, and here I just let you fill in the blanks, and I did the same thing, I realized. Okay, I'm gonna switch over, and where's mine? All right, so there's that first equation based on the formula. The total is 100, is 2 lengths plus 2 widths. Now this next one is the one you got to be, read carefully. The length is, so L equals, right? Length is 10 more than 3 times the width. 10 more than 3 times, or 10 plus 3W, 3W plus 10, that doesn't matter for addition, right? So it makes this work well as a substitution problem. Put all of this in instead of the L, so there it is. Just be careful when there's kind of lots of pieces like this that you don't forget the rest of that other equation, right? There's the 100, there's the substitution, and there's those other 2 W's at the end. Distribute, just to the parentheses, right? 6W plus 20, I scribble, plus 2 more W's. Did 2 steps at once in my head here, I suppose. Add the W's was 8W, subtracted the 20 from both sides, left 80. So 80 was 8W, divide by 8, and the width is 10. Watch out for units on a problem like this. Well, Mom's pretty good, gives them to you often, but think about it. So the width was 10 feet. The length, right, just plug it in here. The length equals 3 times the 10, right? 3 times the 10 is a 30 plus the next 10. So 40, the length was 40 feet. Okay, perimeter, hopefully one that we're pretty familiar with. Number 10 is like one of those multiple choice types that we looked at yesterday in the applications in 5.4. Here's where I kind of usually say, oh, the first equation is kind of the easy one because you just add the different quantities together, and then the second one talks about how much money each part was worth. Right? Adult and children's tickets, what are we looking for? The end of the last sentence usually tells you, how many of each kind of ticket, how many adult tickets and how many children's tickets. So, A plus C, right? Just the quantities, let one variable equal the number of adults, the other variable is the number of children. And there was a total number of 275, and then the value, $7 times every adult and $3 times every child ticket, added up to a certain total.
Do you mind going over a couple of these word problems on the board?
On the board? Well,
like actually walking us through it?
Okay, I thought I just kind of did on the last one.
Oh, okay then.
Does that look like, I mean, was that, did you want a little more presentation on that there? Or just, I don't mind doing that on the board, okay? Let's hang on a second. Let's see, I'll get out of here and, yeah. Oh yeah, there, oh, my bad hair, haha. Let's see, find that again on paper. Did you want me to back up and do more on the the perimeter problem?
The perimeter problem was fine, that I understood. It's more just kind of taking out the pieces.
Yes, this last,
where they go in the problem.
This one, number 10 in particular, is, you might say, newer for us. And hopefully maybe number 11 looks again, a little more familiar, but sure. All right, so like I was suggesting for the multiple choice kinds of problems yesterday, remember they gave you like a choice of 4 or 5 systems. Which one really describes the information in the problem? Well, we have adult and children's tickets they're being sold. And so I might do something like say, let A be the number of adult. And you can use X or Y. In particular, I guess be careful that mom doesn't ask you to use a specific variable, okay? Number of adult tickets. And maybe let C be the number of child. That's what we're looking for. That's why I kind of went to the end of the problems. End of those word problems is often where they tell you, find this, right? Look at the last sentence. What did I do there? So here are the two variables that I've chosen to use, just A for adult and C for child. X or Y, whatever you want, as long as mom isn't being picky about it. Okay, yeah, be real careful about that. Now, what do we have here? That first sentence, the total number of tickets. So this is a quantity of adults, this is a quantity of children. The total number of tickets sold was 275. So that gets you your first equation, right? You just add those two quantities, and that's supposed to add up to 275 tickets that were sold. Okay. So I often say that's typical of this kind of problem. There's usually just a total quantity where you add them together. And now the second equation talks about, well, how much money did we get from all of them? Well, the adult tickets are $7 each. So 7 times the quantity, right? That's how much adult money you got. So 7 times the amount of adult tickets sold. And what's my problem say? $3 for the cost of a child ticket. So 3 times every child ticket. And the total amount of money in the problem, what, $13.05. So that's what you got. I hope you can pull out of those sentences and build your system that way. And now you get to look at that and say, oh, well, all right, what technique do I want to use? Those are individual, 1A or 1C, not too difficult to solve for one and use substitution. Or overall, the numbers aren't that big or cumbersome. You might say the elimination method might not be too difficult to use either. I think I'm going to take that first one and multiply it by -3 myself. Now, if I was going to do substitution, I would just, maybe subtract the A, and then C is equal to a bunch of stuff, and I'd have to replace the C, or other way around, replace the A. But if I multiply everything times -3, right, those C's are going to go away in a minute. Now, let's see, that's 225, 6, 8. Got your calculator handy. Pretty sure I did that correctly, mental math. And now, oops. Now I'm adding together, left me 4A and 5 minus 5, 10 minus 2, that's a 25, right? 10 minus 2 is 8. 12 minus 8 is 4. Yeah, 480. Checking my answer key over here on the side, I guess. 4A was 480, so divide by the 4 on both sides, and I get 120 A's. 120 adult tickets were sold. Okay. And now I've got to find the number of child tickets. I probably use this first equation and say 120 plus the C added up to 275 total. Subtract the 120. And what's that, 155? There were 155 child tickets sold. Hope that helped, walking through like that. But just, keep your eye out for, I guess, part of it just a quantity and the other part of it is multiplying by what it's worth. There was a homework problem in 510 of similar construction, but it was nickels and dimes. all right? Bunch of coins in my pocket. I had nickels and dimes and a total number of coins. Nickels were 10 cents and, no, other way around. Nickels were 5 cents and dimes were 10 cents, and it added up to 500 something cents, right? But the same kind of idea. There's just a quantity of objects and then coming up with a value for that quantity. All right, that's good enough. Last one, right? Last one on that worksheet. Do you have that worksheet in front of you? Or maybe should I share that again? Just, and then I'll come back to it. Where is my screen again? Ta-da. There it is. Okay. And there's all those answers, by the way, in that worksheet that I posted online. Number 11. And again, I'm glad to work that out on the board here in a second, but maybe you can get a head start. Think about basically got to figure out what's the shape of these equations going to be. So you move. Truck rental agency charges a fixed amount plus 10 cents per mile. And I've tried to, you might say, drill in or emphasize, oh, that's a MX plus B. B is that fixed amount. I rent that truck and never drive it, it still costs me $70. But then 10 cents is your slope, right? $0.10 is your slope. The second equation, similar shape, all right? $100 fees, but cheaper per mile. So again, an MX plus B shape. So that's often the first chore, right? Figuring out what shape is this information going to end up in. I'm glad to go back to the board here. Now that first one, I'll just say, let's say it was cost, huh? Was $70. Where is that in front of me here? A $70 fixed amount plus 10 cents per mile. There, I just made up a couple variables, cost and M for mile. I usually avoid M because we save it for slope, but okay. Oh well. And here I wrote it as y equals b plus mx, right? That's the slope. I'm gonna put the x in there. I'm sorry, folks. It bugs me. But mx plus b or b plus mx. Sometimes it's easy, we think it through easier as, oh, there's the fixed amount and then plus this amount that varies. The other one, $100 fee and only 5 cents per mile. Get all your extra zeros in there. So that's the system you want to come up with. That should look like two of those equations that are already solved for y. And the problem says, for how many miles will it be the same cost? So how many miles means we're going to solve for that x to start. But here we set them both equal to each other. This is a substitution type problem, right? If they're both equal to c or to y, plug one of them into the other side there. And there I am doing the substitution and the rewrite. Okay, now, well, I got a few decimals, but calculator.
I have a quick question on this.
Sure.
So if I first looked at this, I would have thought to do the elimination method and kind of like multiply the bottom equation by 2. Would that be wrong?
I think that works too.
Oh, okay. I was just making sure if like both of the ways of going about it would work. Okay.
Yeah, I mean, it's kind of not that usual x and y on the same side form when we use the elimination method. But yeah, if you multiply this by, say, like -2, right, to get up to -10, is that what you were thinking?
Exactly, yeah.
Yeah, so you'll end up with, well, all your c's on one side, and actually and then the number right there. And maybe I'll do that just, so if I did this all by -2, right? I'd get -2c plus 2 equals -200 minus 0.10x. Oh, somebody's trying to call me. My phone in the other room is ringing. Now, and if I added those two together, what do I have? -c equals -270. It'd be a -130, or the cost is 130. Now, and that is the value I have on my answer key. Careful, that was the, if you do it that way, right? I came up with the cost first, and now the problem asks for how many miles. So you still do need to find the x value. You'd have to plug that that 130 back in for c and solve for the x. Okay? Solve for the x value. I'll let you finish that up and see if we get to the same place.
Thank you for going over that.
Yeah. Oh, and it's great if you understand well enough to use a different technique and it works. That's good. All right, let's see. Now from here, I think I'll subtract the x's. All right, so if I subtract the x's, and if you allow me, I'm going to subtract the 70 here. So it leaves all the x's over here. And so that's going to be 30. Kind of did two things at once. Now if I divide by that 0.05, where's my calculator? My answer key tells me that x equals 600 miles. If you've got your calculator handy, you'd be dividing 30 by 0.05. Should come up 600. 600 miles. And notice on this problem, that was answer for A, and then I didn't have a B, haha. But part C, I wrote, what will the cost be? What would that cost be if you know, where the cost is the same for both options if you drive 600 miles. So you got to put that 600 in for one of the x's and do the math, do the simplification to come up with that C value. And just a minute ago, we figured out the C was $130 is what you should come up with. If you plug the 600 in for x, either equation, doesn't matter. Okay. Well, at that pace, right? At that pace, roughly or not quite 5 minutes per problem, we got through all 11 of those problems in 50 minutes. If you're that comfortable with that material, right, you've got 75 minutes on your test on one day. I gave you an extra 15, right? So I'd like to leave you the thought that hopefully that makes it manageable and you're, you won't get too stressed out about the time constraint, right? But I would encourage you, I wondered after that last test whether folks were doing all their scratch work and then even some of you ran out of time, but I could imagine just couldn't get it back into the MOM fast enough. Make sure you leave time to enter your answers in MOM. Yeah. All right, folks. So I'm going to sign off for today. Well, you've got homework that's due on Monday, but Monday night as usual. Your last hand in homework due on Monday. None assigned next week. Okay, so I'm sorry it's a Monday after your weekend, but yeah, I got to show up Monday and take the test as usual. Find yourself the 75 minutes to do that. Contact me with questions if you have them. Otherwise, I'll be around Monday, but otherwise I'll see you Tuesday. Huh? Okay, take care then. All right.
Thank you.
You're welcome. See you.